I'm just going to do a little quick tutorial more than anything. It's not a tutorial, it's more like an update. But more than anything else, want to test out my OBS system and show you what I've got set up. This is what I call me cam. We've then got a rostrum camera, which allows me to show you the bits that I'm going to be working on. We've got a much closer, tight up camera, which allows me to go, that's more like based on a microscope camera, that allows me to look close at what we're doing. We've got an arena cam, so that I can actually look at the arena, and when we're building programs I can go and have a look at the programs. And more than anything else, this is to see how much noise I'm getting from the fans on the computer. If they're obtrusive, then I'll go over to a lapel mic. I probably go to a lapel mic anyway. I've got program cam, which allows me to show you the programming as we are developing it, and then finally circuit cam, which has got a little bit of something that I want to show you today. So I'm going to go over to rostrum cam. A lot of the feedback I was getting, particularly from Camp Piva, was saying, why do you not use 360 servos? And I'm going to say, there isn't really a reason. It's just over the years I've just got so used to DC motors, and so what I thought I'd do is I'll get over some servo motors, and then just have a quick look at them. I've got a standard servo there, 360 servo there, and a mini 360, which might be interesting to come back and look at doing mouse bots, because that's an interesting piece of robotics all on its own. So this is a little servo tester, and what I've done is I've actually set it in the neutral space. So on a servo, I'm cheating, I'm not going to let you see what there is. On a servo, if you move that left at the servo, now some of you use servo, 360 servos now, but a standard servo just literally follows the dial. What you get on a 360 servo is, as you turn one direction, where the servo stops, your motor keeps going, and as you add more turn, what effectively happens is the motor turns faster. So what they're doing is they're effectively solving all the pulse width modulation control for you, which is great, but it just sort of throws it a little bit back in your hands, because you're effectively going to have to give it that centre signal all the time to stay still, and then you could just turn it up, but as you can see they are fairly pulsy. There's a certain amount of inertia in there, and one of the things I'd like to look at is that pulse width modulated control. But what I'll do is I will build one with servos, and we'll do a comparison later. But thanks Camp PV for your feedback. I wanted you to know I'm not ignoring you. I am actually looking at I've looked at the servos, and I haven't dismissed them in any way, shape or form, but I am intending coming back to them. Okay, so what have I brought you in to look at today? So initially, one of the things I wanted to do was do a quick tutorial on how I want to put together the sensors. So what we've got is we're using a nice little whisker switch, and the idea being that whisker, when that whisker goes down, the switch clicks, and it will literally turn the LED off. What I will do is I'll fairly quickly preparation. I thought I had this set up. No, I do. So that's the arrangement with the motor control, and so what I've got is effectively the motor control is literally got the battery going, and at the moment I put a switch on, so putting the battery in is the switch, and what that does is that actually puts the power onto the motor control. But I've also put a 2.1mm jack on there with a view that that will then go straight into the Arduino, so that what you've got then is you've got your little Arduino making its own 5 volts, and then using this system whereby it's got the pins there, we'll literally put in, well, I don't put it on anything, it's not actually going to be programming, I'm just literally putting it on anything, just to really show you that what that does then is turn that LED on, and as the switch operates, the LED goes off. Now the reason I'm suggesting we build the switches like that is that feedback, particularly when you're new to programming, is one of the most valuable things you can have. Now you can see when a motor's running, it turns. You can see when a lot of things are happening, but sensors, without any form of, he says coming up with his hand, without any form of feedback, then how do you know what's happening? So now we know that that white line there, which goes into your signal, has got power on it because the LED's lit, and it hasn't got power on it now. So if we're not detecting it in our software, then the software's faulty. I'm not going to go into setting this all up, partly because I just want to discuss how this circuit works. So if we actually go over to the circuit, it is nothing more than you've got 0 volts, 5 volts, and your serial pin, which is your red, white, and your black in your cable, which the red's in the middle because of where the 5 volts is, and then you've got the signal pin and the 0 on either side. So if you actually swap it out, get it wrong way around, all you're doing is you're putting your 0 volts through, you can't short it out, in other words. So that represents your relay, which is normally closed. So the power is going to that crossroads there, and is going down to your signal pin, and it's then going through your LED and through the 330 all the way back to 0. Now I still put a 10k on there because that guarantees that even if you burn that LED out, what that does, it allows the system to depressurize, and I do sort of equate electricity to water a lot of the time, because it does seem to run very similar. You know, if you've got water in a hose, then if you take the actual fitting off the end and it's a stop end, you still have pressure in there, and if you undo it at the even if you turn the tap off, you do it there, you get that momentary splood and you get half a cup of water, it goes everywhere. Well, the electricity is the same. When you put 5 volts into that line there, basically that 5 volts will, without that 10k and without the diode, if that just went straight round to the pin, the resistance is so high in these pins these days, because the chips are so well made, that you can sometimes be 4 or 5 minutes before that voltage drops, and so you end up with a situation where you think the switch is closed and your software says the switch is closed, and then 2 minutes later it suddenly works again. You think, well, hang on a minute, why did my software work then and not now? And it's purely because the pressure's not dropped in there. So that is like putting a pinhole in the hose pipe, so that when that switch closes, or when that switch goes over to the empty terminal, that pinhole lets the pressure out. Now then, in a hose it might take 3 or 4 seconds. In electronic systems it'll be microseconds. But because it's 10k, it is like a pinhole, so it isn't actually going to let all the water out once the pressure's dropped. It just stays there. So the LED and the resistor could do the same job, but I do believe in good practice, and so the diode and the resistor, which stops the diode pulling too much power and burning itself out, is your additional, but that's your visual feedback, which again is back down to good practice. The 10k guarantees that the system will always work properly, even if that LED burns out. So that's how I'm suggesting we build the sensors, and I'm not going to go into what goes where today. I just want to have a quick look at the kit. So let's take the battery off that. He says, of course, whatever you want to do, just quickly, not a chance. Right, so I'll move that out of the way, and what I'll do is I'll then bring in the kit, which that's the kit that I decided to go for, a little cheap kit off eBay. And what I did is I bought two, so I built one with a view to getting into this. And I've got to be honest, they are fragile. Knowing what I know now, I would probably turn around and say, let's get a better kit. But for now, we've got this one. I would tend to say leave that paper on. You take the paper off, it doesn't actually make it any better. That paper is really just to make it shiny, keeps it shiny. For what it is, I'd leave it on, add the strength, because it literally, I broke the motor housings just by pressing down, putting on the third wheel, and I've had to super glue all the motors in, which is a downside if you're actually trying to change things later. So over in the UK we have a children's program called Blue Peter, and in the traditional Blue Peter it is the one I built earlier. Now and again, although that's set up, I don't want to go through all the setup of the wiring, I don't want to do it, but one of the things I do want to look at, over here we have a thing called blue tack. Now then, blue tack is literally used for sticking pictures on the walls, and it's literally like a plasticine that's sticky. You roll it up, get it warm in your hands, and every component on here at the moment is held on with blue tack. Partly because I don't know just where we're going yet, and so I don't want to burn any bridges. I don't want to glue things on, I don't want to find things, I'm just literally putting blue tack underneath to hold it. Now let's have it. The intention is for this to just be a quick test of OBS more than anything else, test of the system, and get an idea what I need to know. I've forgotten even to turn the lights on, so we're probably working in a much darker than I was expecting. Partly because I just wanted to make this quick, and it's going to, not only is it quick, clean, it's not clever, and it looks like it's going to be a bit basic, but it gives you an idea what we're looking at. So, and really more the test of the OBS. So what I want to do is, the next video I'll actually go through when I'm setting these up, and then the video after that we'll go through a basic programming to actually get the robot running, or the table bot running. And then the last video that I'm going to do is going to be looking at high level options just in this basic configuration, and then I may do one after that, adding some more intricate sensors. But I want to just go for, there's a lot you can learn just in a straightforward, simple table bot with nothing more than touch sensors. So what I'll do is I'll finish on the arena. He says, if I can remember what number I put the arena on. And what I'll do is remember this little guy, just let him go around the arena in the closing bit. So to get an idea of the arena, I might see if there's somewhere I could actually correct the swell in the middle of that. Very wide lens, and by its nature it is going to be distorted. But at least it allows us to look at the way that the robots will perform, and I'll be able to look at the programming that we've put in, and particularly in the early stages how that fails. That'll do it for this first OBS video.